The tech behind India's new futuristic multimodal megahubs. Imagine stepping off a plane, walking a few hundred meters, and boarding a bullet train without ever touching a road. Now, imagine that same building also connects you to a metro line, a highway, and a cargo terminal moving containers around the clock. This is not science fiction. This is a real category of infrastructure India is racing to build right now, called multimodal megahubs. These are not simple train stations or ordinary airports. They are enormous, interconnected transport cities designed to move people and goods with almost no friction at all. Behind their glass towers and sprawling platforms sits a hidden layer of technology most passengers will never notice, yet it controls almost everything happening around them. This is the story of the invisible engineering making these megahubs possible, and why they may quietly become the backbone of India's future economy. Let us start by understanding exactly why India needs these hubs in the first place. For decades, India's transport systems grew separately, almost as if they were designed by people who never spoke to each other. Airports were built in one part of a city, railway stations in another, and highway networks somewhere else entirely, often with poor connections between them. A passenger landing at an airport might need an hour just to reach the nearest train station, wasting time that added up across millions of daily journeys. Cargo faced the same problem, sitting in trucks for hours simply waiting to be transferred between a port, a railway yard, and a warehouse. Every gap between these systems quietly drained money, time, and fuel from the entire economy year after year without most people noticing. Planners eventually realized that fixing this problem meant more than simply building better roads or faster trains individually. It meant designing entire transport ecosystems where every mode, air, rail, road, and metro, worked together inside a single coordinated structure. That idea became the foundation for India's new generation of multimodal megahubs, now rising in cities across the country. But building a facility like this is more complicated than simply placing different transport systems next to each other. It requires an enormous amount of invisible technology working together in real time, and that's where the real story begins. At the heart of every multimodal megahub sits something planners call a digital twin, a complete virtual copy of the entire facility. Before a single brick is laid, engineers build this hub inside a computer, simulating how thousands of people and vehicles will move through it every single day. They test where crowds might form during rush hour, where cargo trucks might create bottlenecks, and where emergency exits need to be widened. This digital twin keeps running even after construction finishes, constantly updated with real data flowing in from sensors placed throughout the physical building. If a walkway becomes overcrowded at a certain hour, the system can detect the pattern and suggest changes before it becomes a dangerous problem. This changed everything about how these hubs are managed, turning static buildings into structures that essentially think and adapt on their own. Engineers describe it as giving a building a nervous system, one capable of sensing stress points long before human staff would ever notice them. And that nervous system depends entirely on a dense, hidden network of sensors spread across every corner of the facility. Underneath the polished floors and glass ceilings of these megahubs lies a vast web of Internet of Things sensors quietly collecting data every second. These sensors track foot traffic, air quality, temperature, noise levels, and even the exact number of empty parking spaces in real time. Cameras equipped with artificial intelligence scan crowds not to identify individuals, but to detect unusual patterns like sudden overcrowding or abandoned luggage. When a certain corridor becomes too crowded, the system can automatically adjust signage, lighting, or even announcements to redirect passengers toward less congested routes. Escalators and elevators are connected to predictive maintenance systems, which detect early signs of mechanical stress long before a breakdown could ever occur. This might sound like a small detail, but a single broken escalator during rush hour inside a hub moving hundreds of thousands of people can cause chaos within minutes. By catching these problems early, engineers avoid disruptions that could otherwise ripple across an entire day's schedule of flights, trains, and buses. But sensors alone cannot manage a facility this complex. They need a central brain capable of processing all of this information instantly. That brain exists inside a facility most visitors never see, a command and control center humming quietly somewhere deep within the hub. Massive screens display live data streams from every part of the building, tracking flight arrivals, train schedules, traffic flow, and security alerts all at once. Artificial intelligence systems constantly analyze this information, predicting problems minutes or even hours before they would become visible to an ordinary observer. If a flight is delayed, the system automatically recalculates connecting train schedules, parking availability, and even staffing levels needed at ticket counters nearby. If a sudden storm threatens to disrupt bus routes outside the hub, the system can alert staff to prepare alternate transport options before passengers even step outside. Engineers compare this control center to the nervous system of a living organism, constantly sensing, adjusting, and responding without ever fully stopping. No one expected transport hubs to eventually resemble something closer to a spacecraft control room, yet that is exactly what many of these facilities now look like. And keeping all of this running smoothly requires something else most passengers never think about at all: an enormous, invisible flow of electricity and data. Every multimodal hub depends on an extraordinary amount of power, running thousands of sensors, screens, servers, and machines simultaneously without a single moment of interruption. To meet this demand sustainably, many of these hubs are being built with rooftop solar panels covering acres of space above platforms and parking structures. Some hubs are designed to generate a significant portion of their own electricity, reducing pressure on the surrounding city's power grid during peak hours. Battery storage systems sit quietly behind the scenes, ready to instantly take over if the main power supply ever experiences even a brief disruption. This matters enormously because a power failure inside a hub this large could trap thousands of passengers in the dark within minutes. Alongside power, these hubs also require enormous bandwidth, since nearly every system inside them depends on constant, high-speed data transmission. Fiber optic networks run beneath the floors like veins, connecting sensors, cameras, ticketing systems, and control centers into one seamless digital environment. Fifth-generation wireless networks are being built directly into the architecture of newer hubs, ensuring passengers and machines alike stay connected without delay. This level of connectivity allows something that would have seemed impossible only a decade ago: fully automated, contactless movement through the entire facility. Walk into one of these new mega hubs and you may notice something unusual. Almost no one is standing in a long line. Facial recognition and biometric systems allow passengers to move from entry gates to security checks to boarding areas without ever showing a single paper ticket. A traveler's face becomes their ticket, their identification, and their boarding pass, all verified instantly through cameras linked to a secure central database. This technology alone can cut passenger processing time dramatically, transforming what used to be a slow, frustrating queue into a smooth, almost invisible walk through the building. For a country moving hundreds of millions of passengers every year, saving even a few minutes per person adds up to an enormous amount of collective time. But the technology inside these hubs does not stop at passenger movement. It extends deep into how cargo and logistics operate as well. In fact, some of the most impressive engineering inside these mega hubs is completely invisible to ordinary travelers, hidden away in massive cargo terminals nearby. Multimodal hubs are not just about moving people, they are becoming critical nodes in India's rapidly growing logistics and freight network. Automated cranes and robotic systems now lift shipping containers directly between trains, trucks, and cargo planes without requiring constant human intervention. RFID tags attached to individual packages allow the entire system to track goods in real time, from the moment they arrive to the moment they leave. A single container can be automatically routed toward the fastest available transport option, whether that means a waiting truck, a freight train, or a cargo flight. This level of automation dramatically reduces the time goods spend sitting idle, which in turn reduces costs for businesses and eventually for ordinary consumers. Warehouses attached to these hubs increasingly use robotic sorting systems capable of processing thousands of packages per hour with remarkable precision and speed. Some facilities are even experimenting with autonomous vehicles operating entirely within secured hub zones, moving goods short distances without a human driver at all. This changed the entire economics of freight movement, turning what used to be a slow, unpredictable process into something closely resembling a precise mechanical rhythm. And this precision matters enormously for a country trying to compete with global logistics giants on speed, reliability, and cost. Perhaps the most important piece of technology behind these mega-hubs is not a machine at all, but a shared digital planning system. Much like the master infrastructure map used to coordinate India's highways and railways nationwide, these hubs are built using detailed, unified digital blueprints from day one. Every utility line, drainage system, fiber cable, and structural beam is mapped digitally before construction even begins, allowing different agencies to work from the exact same plan. This prevents the kind of costly, chaotic overlaps that plagued Indian infrastructure projects for decades, where one department's work accidentally damaged another department's cables or pipes. Engineers can simulate decades of future growth, testing how a hub might handle double or even triple its current traffic long before it becomes a real problem. This forward planning is critical because many of these mega-hubs are designed to remain functional and efficient for 50 years or more into the future. No one expected a filing cabinet full of blueprints to eventually become a living, constantly updated digital model shared instantly across dozens of agencies. But that is exactly what has happened, and it may be the quiet reason these massive, complex projects are being completed faster than anyone predicted. Across the country, real examples of these mega-hubs are already beginning to take shape, moving from blueprints into physical, working structures. Near Delhi, a new international airport is being built with direct rail, metro, and highway connections designed into its foundation from the very beginning. In central India, logistics parks are rising around existing industrial zones, combining rail yards, truck terminals, and warehousing into single seamless facilities. Coastal cities are building hubs that connect major ports directly to rail networks, cutting the time it takes for goods to travel from ship to shelf. Each of these projects looks different on the surface, shaped by local geography and local industry, but underneath they all rely on remarkably similar technology. Sensors, digital twins, automated systems, and shared planning platforms form the invisible backbone connecting every one of these seemingly different projects together. This shared technological foundation means lessons learned at one hub can be applied almost instantly to hubs being built elsewhere in the country. What once would have taken years of separate trial and error is now happening in a fraction of the time, thanks to this connected approach. Building hubs this complex has not been easy, and engineers have faced serious challenges most people never hear about. Integrating dozens of different technology systems built by different companies using different software often creates unexpected conflicts that take months to resolve. Cybersecurity has become an enormous concern, since a hub this dependent on data and automation becomes an attractive target for anyone wishing to cause disruption. Engineers have had to build multiple layers of digital defense, protecting everything from ticketing systems to cargo tracking networks from potential attacks. Training staff to work alongside these advanced systems has proven difficult, requiring entirely new skill sets that did not exist in India's workforce a decade ago. Universities and technical institutes are now racing to create specialized courses focused specifically on managing and maintaining smart transport infrastructure like this. But despite these challenges, progress has continued steadily, driven by a clear understanding of just how much these hubs could transform the country's economy. Every problem solved along the way becomes knowledge that makes the next hub easier, faster, and cheaper to build. The economic impact of these mega hubs reaches far beyond the passengers and cargo moving through them every day. Businesses locate factories and warehouses nearby specifically to take advantage of the speed and reliability these connected transport systems provide. Entire industrial corridors are beginning to form around major hubs, creating jobs in construction, technology, logistics, and countless supporting industries. Real estate near these hubs often increases dramatically in value as developers rush to build offices, hotels, and residential complexes nearby. Economists studying similar hubs built in other countries have found they can boost regional economic output significantly within just a few years of becoming operational. For India, a country still building much of its core infrastructure, these hubs represent a rare opportunity to leap directly into some of the most advanced transport technology in the world. Rather than slowly upgrading old, disconnected systems piece by piece, India is building entirely new, integrated hubs designed for problems the world will face decades from now. This approach allows the country to skip certain outdated stages of infrastructure development that older, wealthier nations were forced to slowly work through. What makes this story remarkable is not just the scale of construction, but the sheer amount of invisible intelligence packed into every hub. Passengers walking through these facilities may never notice the sensors above their heads, the cameras tracking crowd patterns, or the servers processing data beneath their feet. They will simply notice that their journey feels smoother, faster, and somehow less stressful than transport experiences they remember from years earlier. That quiet, seamless feeling is exactly the result engineers have spent years working to achieve, hidden behind glass walls and polished floors. Each megahub represents thousands of small technological decisions made by engineers determined to solve problems that once seemed impossibly complicated. And as more of these hubs come online across the country, they begin to form something larger than the sum of their individual parts. Together, they create a connected national network where a passenger or a package can move across the entire country through a chain of intelligent, cooperating facilities. This is ultimately what these megahubs represent, not just buildings, but a new operating system for how an entire nation moves. For decades, India's transport infrastructure struggled under the weight of disconnected systems, wasted time, and missed economic opportunity. Now, quietly and steadily, a new generation of engineers is replacing that old reality with something faster, smarter, and far more connected. Every sensor, every automated crane, every digital twin represents a small piece of a much larger transformation taking place across the country. The world once assumed India's infrastructure would always lag behind, weighed down by scale and complexity too large to manage efficiently. These megahubs are quietly proving that assumption wrong, one intelligent, interconnected facility at a time. And as more of them rise across the country, they are not just changing how people and goods move, they are changing what India believes it is capable of building.